Hi guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. My courses are absolutely free of charges and my courses are going to help the students who are preparing for CSIR NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT-Jam exam and other exams are related to physical science. Okay, so this is the lecture number 9 of mathematical physics. We will solve some important questions uh, related to divergence, curl and gradient. Okay, these questions are very important question and I'll tell you the trick to solve those questions, and then calculation is going to be simple. Okay, and also I thank you the people who subscribed my channel, and I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my lectures, which are going to help you to crack the exams related to physical science. Okay, so I'm going to start now. Okay, so lecture number 9, and the first question, we'll start with simple question. Okay, question number first. This is we have been given phi equal to xyz. Okay, xyz, and we need to find gradient of phi. Okay, very simple. So the solution is going to be gradient of phi. Gradient of phi is going to be gradient of xyz. Okay, and we'll put the value. So value of del is del upon del x I cap plus del upon del y j cap. Okay, just give me 1 second guys. Okay, 1 minute, there is some issue, I have to sort it out first. Okay guys, that is sorted out. So I'll start now. So this is going to be plus del over del y k cap into x y z. Okay, so we'll simplify it. So it is going to be, we'll simplify first this with this, right? We know the partial differentiation of x partial differentiation will do with respect to x for this. So this is going to be yz I cap plus this will be xz j cap plus xy k cap. Okay, so this is the simple question and this is the answer guys. Okay, sorry, so this is the one, so this is the answer. Question number 2, we'll solve. Question number 2 is, this is also simple one. This is phi is given, that is sin z, sin x, sin y and sin z, okay, and we have to find out gradient of phi. So this is, we'll solve it simply. In the same way we solved the question number 1, okay. So this is going to be del upon del x I cap plus del upon del y j cap plus del upon del z k cap, okay, and this is sin x, sin y and sin z, okay. So we'll solve it. So this is going to be gradient of phi is going to be this one. This is going to be, so we'll operate this with this, right? So this is sin x is going to be cos x, differentiation of sin x with respect to x is going to be cos x. This will be cos x sin y sin z, sin y sin z I cap plus, this is going to be cos y, because differentiation of this with respect to y is going to be differentiation of sin y is going to be cos y, okay. So this is going to be cos y sin x sin z j cap plus, in similar way, cos z sin y sin z k cap, okay. So this is the one, and this is the answer, guys. Very simple question. So this one, right? So we have found gradient of phi. Okay, next question. We need to find question number 3rd. This is phi is given r, okay, and we need to find gradient of phi, okay. Very simple question. So similarly we'll solve it. This is going to be gradient of phi, okay. So del upon del x I cap plus del upon del y g cap plus del upon del z k cap, okay, and the value of r we know. Value of r, since I'm going to write the value of r is root x square plus y square plus z square, okay. This is the value of r. So we'll write it here, x square plus y square plus z square to the power 1 by 2 we can write, right? So we'll solve it. So this is going to be 1 upon 2 so I'll tell you the trick from here, okay, so that it will be, we can easily solve it. So here what I'm going to do is, I'll write sigma I, okay, iota cap del upon del x and r, okay. This is this one, x square plus y square plus z square to the power half, okay. This will solve only one term, and remaining term will write by symmetry. We'll write by symmetry, because that's why we have used sigma. Okay, so this is going to be sigma I iota cap, and we'll solve it. This is going to be 1 upon 2 differentiation of this 1 upon 2 into this way. This is going to be 1 upon 2. I'll write directly. Okay, very simple differentiation. So this is going to be 1 upon 2 root x square plus y square plus z square, okay, into 2x. Okay, we consider it t and we differentiate it, and then we differentiate it to, right, with differentiated 2x of x square, right? So this is the value, so we can write it now. Gradient of phi. This is very important trick, guys, because if you just need to solve one term, remaining term you can write easily. Okay, and we have to use sigma for it. So this is sigma iota I cap. 2 will get cancelled, so it is going to be x upon r. Why? Because the value of x is x and the value of root x square plus y square plus z square is r, right? So very simple. Now we'll write it by symmetry, or we'll open this sigma. So this is going to be, this value is going to be I cap x upon r plus g cap y upon r plus k cap z upon r. So gradient of phi is going to be x I cap plus y g cap plus z k cap upon r, and this is going to be vector r upon r, right? Since we know vector r is x I cap plus y j cap plus z k cap. Okay, so this is the answer, guys. Okay, so we have taken only one term here and solve it. Okay, so now we'll use the same method solving other questions, and those questions are going to be very easy using this method. Okay, so next question. So this is question number 3, I believe. So question number 4 we are going to solve. Okay, question number 4, and this is gradient of r to the power n. Okay, gradient of r to the power n. So we are going to solve it. We'll solve with the method. This is, will solve only one term. Okay, remaining will write is by opening the sigma or by symmetry. Okay, so this is sigma I. We'll write only first term, iota cap del upon del x r to the power n. Okay, we just have written only one term. Okay, so we can write like this value. Actually the value of this is this. I'll write this as well. Okay, so this is del upon del x iota cap del upon del x r to the power n plus g cap del upon del y r to the power n plus del upon del z r to the power n. Okay, this is the actual term, right? Okay, so we have used this in terms of sigma. Okay, we'll use on, you will solve only one term, remaining will write it by symmetry. Okay, so this is the one. So just I have written this term. Okay, this is the term. Okay, so now we are going to solve it. So gradient of r to the power n is going to be this one. Very simple. We solve it. So this is going to be sigma iota cap iota sigma I iota cap. I will differentiate this. This is going to be n into r to the power n minus 1. Very simple differentiation, right? And del r upon del x. Okay. This is going to be gradient of r to the power n. So this is going to be sigma I iota n into r to the power n minus 1, and this will differentiate it. I have already differentiated this here. This one, right? This gradient of r is 5, right? We can write here this gradient of r, right? So I have already solved. So this value, the value is x upon r, right? This one, del upon del r. So I'll solve it for you as well. So this is going to be, I'll solve it once. Okay, so this is going to be del upon del x. I'll write this value, x square plus y square plus z square. I'm solving it now, and afterward we'll put directly the value of dr upon dx. Okay, so this is going to be gradient of r to the power n sigma I iota n into r to the power n minus 1, and we are solving it. So this is very simple. 1 upon 2, we'll take it as a t, right, and we'll differentiate it. So this is 1 upon 2 into 2x upon root x square plus y square plus z square, right? Okay, 2 get cancelled, and this is going to be sigma I iota n r to the power n minus 1, and this value is going to be x upon r, because the value of r is root x square plus y square plus z square. Okay, so next, the value of this is going to be gradient of r to the power n. It is going to be sigma I iota n. This r will go up, right? So this is r to the power 1, so this is going to be n minus 2, r to the power n minus 2, n into r to the power n minus 2 into x. Okay, right? So we'll take these outside. So this is going to be n r to the power n minus 2 sigma iota x. Yeah, right? We'll open it by symmetry. It's going to be n r to the power n minus 2. This is going to be x I cap plus y j cap plus z k cap, right? Okay, we'll open the sigma, because x I cap is for one term, for one. This is one term, right? So there are 2 more terms, that is, and those are going to be yj cap plus zk cap. I hope you understood this step, guys. Okay, So this is going to be n r to the power n minus 2 vector r, because we know the vector r is x I cap plus y j cap plus z k cap, right? Okay, let me just check. So this is the answer. So gradient of r to the power n is going to be gradient of r to the power n is going to be n r to the power n minus 1 vector r, n r to the power n minus 2, sorry, n r to the power n minus 2 vector r. So this is the answer, guys. Very simple. Okay, let's solve next question now. Okay, next question. This is question number 5th. Okay, question number 5th. Question number 5th is, you need to find out phi is given ln r. Okay, and you need to find out gradient of phi. Okay, gradient of phi. So this is, now again we'll solve it. So this is gradient of phi is going to be we'll take only one term, right? Sigma I, using this method. Okay, sigma I iota del upon del x ln r, right? Now you understood this. That's why I've solved this for you, and I have explained each steps so that I can write here directly. Okay, so this is one. So we'll solve it now. So it is going to gradient of ln r, right? Gradient of ln r is going to be sigma iota, and this will be sigma I iota into, will differentiate this, right? It's very simple differentiation. So this is going to be 1 upon, this is going to be 1 upon r, 1 upon r, and del r upon del x. Okay, so this value is going to be del r upon del x. Okay, so this is going to be 1 upon r, we'll take outside. So this is going to iota sigma I iota into del r upon del x, del r upon del x, and we know this value, right? I have already solved here this one, del r upon del x. I'll write this value directly now. So del r upon del x, I've solved it, and this value is going to be x upon r, x upon r. Okay, for one term. So this is going to be 1 upon r sigma I iota cap x upon r, the value of this x upon r, right? So this is going to be gradient of ln r. Okay, gradient of ln r is going to be 1 upon r, 1 upon r, and this one, right? R will take r outside, so this is going to be 1 upon r square. Okay, one upon r square sigma iota iota x, right? So this is going to be 1 upon r square, and this value sigma I iota ixi is going to sigma I iota x is going to be x I cap plus y j cap plus z k cap, right? So now this value is going to be r square, this value is going to be vector r upon r square, because xi cap plus yj cap plus zk cap is r vector, that is position vector, right? So this is the answer. Okay, so gradient of ln r is r upon vector r upon r square. Let me just check. Vector r upon r square, yeah, that's correct. Okay, next question, that is question number 6. This is important question. So phi is given 1 upon r, okay, and you need to find out gradient of phi. Okay, so we'll find out is, so gradient of 1 upon r, this is phi, is going to be, we'll write one term, this method will take only one term and we'll solve that, and after that we'll open the sigma and write complete term, or by symmetry we'll write complete term. Okay, we'll just solve one term, remaining term will write by symmetry or by opening this sigma. Okay, well, so I'll write it. So this is going to be iota del over del x into 1 upon r. Okay, right? So we'll solve it. So this is going to be sigma iota, sigma I cap, sigma I, then iota is here, iota, we'll differentiate it. So this is going to be minus 1 upon r square, minus 1 upon r square, and okay, it's going to be minus 1 upon r square, and this is going to be del r upon del x. Okay, so this is going to be sigma I. Okay, so we'll take this outside. This is going to be minus 1 upon r square sigma I del r over del x. I have already explained this value is x upon r. So this is going to be minus 1 upon r cube. R will take r outside. Iota cap is also here. Okay, so iota, so this is going to be sigma iota, and this is going to be x I cap, right? This is gradient of 1 upon r. So we'll write it here. So gradient of 1 upon r is going to be minus 1 upon r cube. Okay, we'll open this sigma and we'll write it. So this is going to be sigma xi cap, means sigma, this value is going sigma xi cap, the value is this value is going to be xi cap plus y j cap plus z k cap. Okay, so this is going to be minus 1 upon r cube, this is vector r, right? So this value is going to be minus vector r upon r cube. This is the answer, guys, minus r vector upon r cube. So this is the answer. Very simple and but very important questions which I am solving. Okay, you just need to use this method and solve it, and you will be able to solve this question very quickly. Okay, next question, this is question number 7. Question number 7. Question number 7 is vector A is given, that is r to the power n vector r. Okay, and you need to find out divergence of A. Okay, divergence of A you need to find out. Very good question. Okay, so how to solve this? Okay, so we'll find gradient of A. We'll solve only one term. Okay, remaining term we'll write it by symmetry. Okay, so this is going to be, we can write it like this: sigma I iota into del upon del x dot r to the power n r cap, r to the power n vector r, right? We can write like this. Okay, well, so we'll solve it further. So this is going to be divergence of A is going to be sigma I iota, this is going to be, we can write like this. This is step like with the dot we can take here because dot is between directions, right? So I cap dot del upon del r to the power n vector r. We can write this. Okay, because this is dot product, right? And dot product is between the vector, so dot we can write here. This is not vector, right? So we can take it and we can we can shift this dot here with I. Okay, so this is going to be I dot del upon del r to the power n r vector. So we'll solve it by so use differentiation of two functions, right? First function as it is, then differentiation of second, plus second function as it is, differentiation of first. Sorry, so it is first function differentiation of second plus second function differentiation of first. Okay, so this is going to be sigma I iota. We'll solve it. This is first function, that is r to the power n r to the power n so we can write like that, like this. Differentiation of first, we can do first n into r to the power n minus 1. Okay, and vector r. Okay, differentiation first and then plus, this is going to be r to the power n del r upon r. Okay, this is the one, right? So we'll solve it now. This is like differential, we have done some mistake. This is x guys. Okay, that's why we have taken only one word. This is x, so in that case this is going to be del r to the power n, then del r upon del x. Okay, plus second function first function as it is, differentiation of second. Okay, first function as it is, differentiation second, this is del r vector upon del r. Okay, so this is going to be sigma I dot n r to the power n minus 1. This value we know. Okay, I would request you del r upon del x, note down and memorize it. This value is x upon r. Okay, okay, so this is going to be x upon r plus r to the power n, and this del upon del r, right? This value is going to be iota. How? Well, I'll solve it for you as well. Del upon del r, will write, this is del upon del x, right? Sorry, del upon del x. Okay, we are differentiating with respect to x. So this is del x x I cap plus y j cap plus z k cap. We know the vector value of vector r, right? This is position vector. So this is going to be sigma I cap dot r n into r to the power n minus 2, because we'll take this r up, right? So this is going to be r to the power minus 1, so we'll add with it, so it is going to be n r to the power n minus 2 x plus this value is going to give r to the power n. This is not r cap, okay? R to the power n, this is r to the power n, r to the power n, okay? So r to the power n, this value is going to be I cap, right? I cap, because these term will be 0 and d upon dx, differentiation of x I cap with respect to x is going to be iota, okay? So now this is going to be, I'll write in next page, divergence of A is going to be this one, sigma iota, and this one iota will take inside, okay? So this is going to be n r to the power n minus 1, n r to the power n minus 2, okay? And this is going to be, okay, vector r is also here, because differentiation of first function is this, then second function, and then first function differentiation of second, okay? This is vector r, this is vector r, okay? Vector r is also there. So this is going to be sigma I r to the power n minus 2, and now we'll do dot product with vector quantity, okay? So this is going to be r n into r to the power n minus 2 x. These are not vector quantities, so we'll write together x, and this is going to be iota dot vector r, okay? This one, iota dot vector r with vector, and this is going to be r plus r to the power n, iota dot iota, okay? This is step iota dot iota. We'll do dot product with vectors, okay? So this is going to be sigma iota, and this value is going to be n r to the power n minus 2 and x, and this iota dot r vector is going to be, this is going to be x, okay? I'll write it, that would be very easy for this. I'll write it x into iota x into iota dot vector r is x I cap plus y j cap plus z k cap plus r to the power n. Iota and iota is, iota dot iota is going to be 1, okay? That we know. This is r to the power n, since iota dot iota equal to 1. So this is going to be sigma I n r to the power n minus 2, and this is going to, this value is going to give x, okay? Because iota dot j cap is going to be sorry, I cap dot, this is not iota, guys, my apology, this is I cap, okay? This is not iota, my apologies. So this is I cap dot x cap. So this is going to be this value is going to give x, okay? Because iota dot iota I cap dot I cap is going to be 1, I cap dot j cap is going to be 0, and I cap dot k cap is going to be 0. So this value is going to give x. X means x square, okay? X into x plus r to the power n, okay? This is the value, right? Now we'll we'll write the complete value. We'll remove, open the sigma, right? So then this value is going to be, n r to the power n minus 2, 3 values, right? X square plus y square plus z square, right? Plus this one plus 3r to the power n. I hope you understood this step, guys, because this is the value for one term, right? For second term, the value is going to be n r to the power n minus 2 y square plus r to the power n. For third term, it is going to be n r to the power n minus 2 z square plus r to the power n, right? If we add these, so it is going to be n r to the power n minus 2 will be common, and x square plus y square plus z square plus 3 into r to the power n. This is the value, okay? So this value we know, this is r square, right? This r square. So this is going to be n r to the power n minus 2 r square plus 3 r to the power n. 3 r to the power n, okay? So because we know x square plus y square plus z square equal to r square, okay? So then the value is going to be divergence of A is going to be here r square and r to the power n minus 2. So we solve it, so it's going to be 2 will get cancelled, so r to the power n, okay? So n r to the power n plus 3r to the power n, and this value is going to be, we'll take r to the power n common, r to the power n we have taken common, so this is going to be n plus 3. Okay, so this is the answer, r to the power n plus 3. This is the value of divergence of A, okay? Divergence of A, okay? Well, this is the one. Okay, now question number, this is important question, okay? This is very good question. So this question is easy because we have used that this method, okay? Solving only one term and writing the remaining term, okay? Now question number 8 we are going to solve. Question number 8. So now here you need to find out, so we have find curl divergence of A, right? The value of A is this one, r to the power n into vector r. Now we are going to find curl of r to the power n vector r, okay? This we are going to find. So how we are going to find curl of r to the power n into vector r? We'll solve only one term. So this is going to be sigma i cap cross I cap, not cross, I cap, it is going to be I cap into del upon del x cross this r to the power n vector r, okay? We can write this in one term, okay? Value of this. So cross is, so we'll take cross this side, right? Because this is vector quantity. This is not a vector quantity. So we can write like this, sigma I iota, and this is going to be iota cross del upon del x r to the power n r cap. Now it is r to the power n into vector r. Now it is going to be easy for us to solve. Okay, so we'll write in next page. So this is curl of r to the power n vector r. This value is going to be sigma iota sigma I cap, and this is going to be, we'll solve this one. Okay, I'll show you first. Yeah, this. So we can easily solve this one. We'll use differentiation of two function. Okay, and we know how to do it. So this is going to be cos n into r to the power n minus 1, this one first function, right? The differentiation of first function. This is n into r to the power n del r upon del x okay, into vector r plus r to the power n del r vector upon del x, right? So this is going to be sigma I cap into, this value is going to be n r to the power n minus 1, and this value we know, right? Del r upon del x. This is going to be x upon r into x upon r, will not write cross, into x upon r, and this is plus r to the power n, and this value is going to be, we know that is iota. I'll write it. Okay, I'll write in detail. So this is going to be del upon del x, vector r is x I cap plus y j cap plus z k cap. Okay, so this is going to be sigma iota sigma I cap cross, this is n r to the power n minus 2, because r to the power r is in denominator, right? It will go to numerator, it will become r to the power minus 1, and powers will add it, so it is going to be r to the power n minus 2 x, vector r is also there. Okay, vector r plus, this is going to be, so will differentiate it, right? It's going to be I cap. Okay, because these values are going to be 0, so this is going to be r to the power n I cap. Okay, now we can write this like this. We can do cross product with vectors, so this is going to be n r to the power n minus 2 x, then I cap cross vector r. Similarly here it is going to be r to the power n and this is iota cross iota. Iota cross iota is going to be 0. Okay, so this is going to be curl of r to the power n vector r is going to be this one. Yeah. Okay. this is going to be sigma iota r to the power n into r to the power n minus 2 x I cap cross r vector plus this value is 0, right? So this is going to be 0. So we can write it. So this is going to be like this: n r to the power n minus 2 x I cap cross r vector plus y j cap cross r vector plus z k cap cross r vector. We can write it like this, okay? Right? So by symmetry, we have opened the sigma, right? So this we can write it like this: n r to the power n minus 2, or we can write x I cap plus y j cap plus z k cap together cross vector r. Okay, we can write like this as well. So this is going to be n r to the power n minus 2 n r to the power n minus 2, and this value is going to be vector x I cap plus y j cap plus z k cap is r, vector r cross r, and we know vector r cross r is 0 in similar way like I cross r, I cross I is 0, right? This value is 0, so this value is going to be 0. So curl of r to the power n vector r is going to be 0. This value is 0, guys. Okay, this is the answer, right? Now we'll solve question number 9. Question number 9. Okay, question number 9 is divergence of r gradient of r. Okay, you need to find this value. Very simple. Very simple. So we'll write divergence of r gradient of r, right? So you can write it like this: this is divergence of r into this gradient of r. We know the value of gradient of, I have already solved. This is r upon this. I have solved it, right? The first question, I think. Third question, I believe. This one. This value is this gradient of r, right? This is vector r upon r. Okay, this value is vector r upon r. Vector r upon r, right? Here we'll write, since gradient of r is vector r upon r. I have already solved it for you guys. Okay, so this is going r get cancelled, and this is going to be divergence of vector r. This we know, we can easily solve it. This is del upon del x I cap plus del upon del y j cap plus del upon del z k cap dot r, value of vector r we know, xi cap plus yj cap plus zk cap. Okay, so we'll solve it. So this is going to be this one, 1 plus 1 plus 1, that is 3, because if we differentiate this with respect to x, this is going to give value 1, because I dot I is 1, j dot j is 1, k dot k is 1. Okay, so the value is 3. For this, the value is 3. Okay, so now guys, as we have solved this question, right, gradient, the curl of r to the power n r. So from this we can also conclude, deduce, like curl of vector r, this is also going to be 0, and curl of r to the power r square r vector, this is also going to be 0, or curl of r into vector r is going to be 0, because we have already solved curl of r to the power n vector r is 0. From this we can say this is 0, right? Also r to the curl of r to the power 3 vector r is also going to be 0. Okay, so well guys, these are the important questions which I have solved for you. Okay, now I'm just going to summarize everything whatever I have taught. Just so these are the formulas, I would say, and note down. I'm going to write it with red ink. Okay, so this means divergence of r is going to be 1. Okay, in 1D, because divergence of vector r in 3D we know that is 3. I have already solved it for you. Similarly, divergence of r is 2 in 2D. And divergence of r equal to 3 in 3D. I have already solved it, guys. Okay, I'm just summarizing it, whatever I taught you. And also we have seen curl of r is 0. Okay, similarly curl of r to the power n r is 0. With the help of this is 0. Okay, and we have find divergence of r to the power n vector r. This value is very important one, n plus 3 r to the power n. Okay, similarly gradient of r we have solved. This is vector r upon r, and we have solved gradient of ln r. This value is vector r upon r square, and gradient of 1 upon r also we have solved, and this value is minus vector r upon r cube. Okay, so guys, these are very important formulas, okay, and questions. You need to solve these questions and practice and revise, and and then you will easily memorize these formulas. Very important formula. You need to memorize these formulas as well. Okay, well guys, so I'm going to stop here, and thank you so much for watching my lecture. And also I would request the people who haven't subscribed my channel yet, please subscribe my channel and watch my classes which are free of charges, and which are going to help you to crack the exams related to physical science. Okay, Well, guys, thank you so much. Bye now.